Today we're talking about scatter plots. Let's recall positive and negative slope. If we look at the coordinate grid, a positive slope would go from the left to the right, increasing, while a negative slope would go from the left to the right and decrease. So when you're constructing a scatter plot, which is our goal today, we take data from two different variables and we take their pairs, which are called bivariate data. Okay, make sure that you have that word written down in your notebook. A scatter plot shows the relationship between the bivariate data graphed as an ordered pair. For example, if we were looking at seasons versus viewers, then we can construct a scatter plot to see how many viewers watched the different seasons of a certain television show. For example, in season 1, there were 31.7 viewers. Okay, all bivariate data means is that there's two, like seasons versus viewers. So we can put that in a table in a scatter plot form. For example, list the seasons 1 through 10, and then write down or plot, the number of viewers. If you take a look at this, the horizontal axis is, or my x-axis is the seasons, while the viewers are the y-axis. It's just a different way of showing the information. It's not like a line graph or anything, because instead, this is how it's how the numbers are different over the different types of seasons. Let's look at a different example. Construct a scatter plot of the weight of an alligator at various times after hatching. So the first thing that we're going to do is we're literally just going to plot these points, but first we need to figure out where we want to plot them. So like the weeks would go down here, and then the weight would be in pounds. So we need to put weight. And then we can literally plot the points. Go ahead and try that, and I'll be back in just a second to show you what I did. Okay, make sure that you have paused the video. So take a look at what I did. I have my weight in my pounds, I have my weeks here, and then from here on, as it's increasing, as the weeks increase, do you notice that the weight is also increasing? So we talk about these things and we call them something specific. We call this a positive association, a negative association, and no association. Okay, sorry, I got interrupted, but this is a positive association, a negative association, and no association. When there's no real pattern going on, it's no association. Then we also have linear versus nonlinear. This one is kind of shooting up crazy quick, while this one is forming more of a straight line. That's why it's considered linear. So let's look at some more examples. We can analyze these also based on outliers and clusters. Make sure you have these written down because this will be assessed. Clusters are these groups of data where all of them are kind of smashed together, or you see a lot of data points all right there. An outlier is where there's one just hanging out all by his lonesome. So if we wanted to interpret this scatter plot, we would say that the association, we would talk about the variable association. As the amount of memory increases, the cost increases. Take a look. As the gigabytes get bigger, the cost gets bigger. We can also say that there is a positive association then. From there, we can say that it's linear, because if you look here, it appears to lie on some sort of a straight line. There also appears to be a cluster of data right at the $30 range all the way to 75. I probably would have even counted 25 and up because it's hard to tell that that's exactly 30. But so I would say that right here, about in that area, I made my circle a little too big. Like this area right here is between 75 and 25. So there is some sort of a cluster. There isn't any outliers though. Some people might say that this one is, but if you really look at it, the change is only about $50. It's not like if it was out here, where the change would be literally hundreds of dollars. So go ahead and try this for me. Interpret each of these scatter plots the same way that I did. Tell me the associations, tell me if they're linear, nonlinear, no association, and give me some information about it that you can conclude. All right, so I'm going to show you what I did. On this one, as the time increases, the temperature of the water decreases. So as the time goes up, it's going down, which means it's a negative association. It also appears to lie on a line, so we could call it linear. There are no clusters and there are no outliers. For this one, there really isn't any association. If you look, they're neither linear nor nonlinear, because if there's no association, it doesn't have that clear line pattern. And I, again, don't see any clusters, and since it's kind of all over the place, there aren't any outliers. And that is all I have for you, so I will see you next time.